Hello guys, welcome to the channel, and in this video I'll be talking about finding the area of compound regions, and for that I'll be using Geogebra. Now before evaluating the area, let's first understand what a compound region is. Let's say I do have two functions fx and gx, and let's assume that these two functions intersect each other at many points. If I consider my region of interest over the interval a to b, as you can see, these two functions cross each other at only one point, that is x equal to c. Now as can be seen, the function fx is greater than gx over the interval a to c, while the function gx is greater than fx over the interval c to b. Now the region that is formed here is called the compound region. Now since the region is formed between these two curves, the concept of finding the area between two curves needs to be understood. So for that, we'll first talk about finding the area between two curves. Consider we do have two continuous functions fx and gx such that the function fx is greater than equal to gx over the interval a to b, and the area between the curve is given by the integral a to b fx minus gx into dx. So that's the formula to find the area between the curve. Now as you can see on the graph, the function fx is greater than gx over the interval a to b, and we have to evaluate the area of this region. The area under the function fx is below the curve fx and above the x-axis. So the area under fx will be this complete area, while the area under the function gx will be below the curve of gx and above the x-axis, so this area. Now the area of this region will be obtained by subtracting the area under gx, this area, from the area under fx, which is this complete region. So that's how this area is evaluated, and that is why the function gx is being subtracted from fx and it is integrated over a to b. Now we will use this concept to evaluate the area of compound region. For compound region, let's again consider two continuous functions fx and gx over the interval a to b such that the function fx is greater than gx over the interval a to b, while the function gx is greater than equal to fx over the interval c to b. Now the area of this compound region can be evaluated by dividing the whole interval into two subintervals, that is from a to c and c to b. Now let's first talk about the first subinterval, that is a to c. Over this first subinterval, the function fx is greater than equal to gx, so the area of this region is given by fx minus gx integral over a to c. Similarly, over the subinterval c to b, the function gx is greater than equal to fx, so the area of this region will be gx minus fx integral over c to b. Now these two expressions can be given by a single expression, which is integral over a to b modulus of fx minus gx into dx. This modulus is called as the absolute value function. Now we will move ahead and take an example. Let's consider function fx as sin x given by this curve and function gx as cos x given by this curve, and we will evaluate the area over the interval 0 to pi given by these two vertical lines. Now as you can see, these two curves intersect at x equal to pi by 4 over the interval 0 to pi, and we will evaluate the area of these regions, and for that I'll use GeoGebra. Now I have opened the GeoGebra Classic, and in this I'll first graph the two functions that I did considered, and after that I'll evaluate the area. So first I'll graph the function fx, which was sin x. Sin x, okay, sin x, and now I'll graph my another function gx as cos x. So these are the two functions, and now I'll label them. This is my function sin x, this is my function cos x. Okay, now we want to evaluate the area over the interval 0 to pi. So for that, I'll first graph two vertical lines. First I'll graph the x equal to 0 line, and then I'll graph x equal to pi, another vertical line. Okay, so we do have two vertical line. Now we can zoom in the area. So as you can see, these two curves intersect at this point, which is x equal to pi by 4, and for that I'll graph another vertical line, which is x equal to pi by 4. So this is the intersecting line representing the intersecting point. We do have the intersecting point, and I have graphed three vertical lines representing two different regions, this area and this area. So now we will first evaluate the area over the interval 0 to pi by 4, and over this region, as you can see, the upper curve is gx and the lower curve is fx. So I will use the syntax integral between, and here, since the upper function is gx, so here the first function is gx, the second function fx, the start value will be 0 and the end value will be pi by 4. So that's the area, which is equal to 0.41 square units, and over the second region, which is from pi by 4 to pi, the upper curve is fx, which is equal to sin x, and the lower curve is gx equal to cos x. Integral between, and the first function will be the upper curve, so for this I'll write fx. The lower function is gx, so I'll write gx, and the start value here will be pi by 4 and the end value will be pi. Enter. So I do have the area of the second region given, which is equal to 2.41 square units. The total area will be the addition of the value a plus b, so I'll also compute that here, which is equal to 0.41 plus 2.41. So the value that is returned is 2.82. So the area of this complete region will be 2.82 square unit, and that is all for this video. So guys, if you have anything that you want to know, please do comment. Please like, subscribe and share, and I will see you in the next video. Thank you.